Hello everybody and welcome to the presentation of this work entitled The Hybrid Approach Based on Machine Learning and Multi-Criteria Decision Analysis for Budget-Aware Chronic Kidney Disease Analytics. This presentation is authored by me, Usama Abdellaoui. I'm a member of the LAMSAD laboratory in Hassan First University in the National School of Applied Science in Barshid, Morocco. Also with me there is Professor and Dr. Mohammed Naimi, University Professor and Researcher and in the University of Hassan first in Morocco, and also in the National School of Applied Science in Barshid. We would like to thank the conference committee, session chairs, and organizers for their thoughtful planning, support, and the opportunity to present today this work. In this talk, we'll try to introduce a hybrid machine learning and the multi-criteria decision analysis framework for budget-aware CKD analytics using an open source CKD dataset. The multi-criteria decision analysis (MCDA) frameworks, criteria weighting, and budget-aware ranking will be discussed in depth in the final paper, in the manuscript, rather in this talk. We will hear about data preparation, feature engineering, model selection, and while the MCDA methodology for results sensitivity analysis, as I said, will be reserved for the manuscript. Um, we'll see today the context and the objective of this work. We'll do also some data analysis framework, work on three machine learning models. We will introduce the multi-criteria decision analysis and next steps, and we will conclude this presentation. First of all, the chronic kidney disease is a prevalent progressive condition associated with substantial morbidity, mortality, and health system costs. Diagnosis and ongoing surveillance rely largely on laboratory measurement, yet the cost and patient burden of these tests vary across settings. In this context, machine learning can help by extracting useful signals from diverse CKD data, including laboratory indices, demographic factors, and prior health history to refine risk satisfaction and stratification and monitoring. However, performance alone is not sufficient. In fact, this model must be well calibrated, generalizable, interpretable, and equitable. A multi-criteria decision analysis offers a principled framework to balance discrimination, calibration, and equity under budget constraints. Taken together, chronic kidney disease analytics, machine learning, and multi-criteria decision analysis should offer a budget-aware, ethically grounded decision support, pathway that can guide resource allocation, support adaptation across diverse health systems, and inform policy and practice beyond metric-driven optimization. In this presentation, we propose an integrated framework that couples CKD analytics, machine learning, and MCDA to produce budget-aware ranking or alternatives models, each balancing predictive performance, calibration, equity, cost, and feasibility. We will present and interpret some initial results, as I said in the first slide, with a focus on the machine learning on three algorithms and for the next steps. The tools. We will use three tools today to try to model machine learning algorithms. We will use, first of all, Anaconda. It's a popular open source distribution that simplifies the installation and management of tools and libraries for data science and machine learning. We'll use also the Jupyter notebook. It's also an open source interactive environment that allows users to create and share documents containing codes, etc. And finally, we'll use some Python code. Python is a versatile, simple, and easy to learn programming language. It is widely used in data science, AI, web development, etc. Straightforward, we will use this end-to-end machine learning workflow for the chronic kidney disease data from loading and cleaning to training. Perhaps we will not see the tuning and evaluation today. First of all, we will load the data set, we'll import CKD data, we'll inspect and shape the column names. We'll also perform an EDA on the data set and exploration. We'll explore the data, we will check for missing values, null values, also the data types, etc. We'll try to clean the dataset. We'll handle missing values. We'll correct obvious error and ensure the consistent data types. We'll also divide the dataset into train and test set, and we'll split the data, as I said, to train set and data set. We'll train some models. As I said in at first, we'll focus on three algorithms, and for the tuning and the fine tuning and the evaluation and the comparison, we will discuss them in the manuscript. Here we will be using an open source Kaggle hosted version of the UCI CKD dataset. It contains a mix of numeric and categorical attributes related to kidney function, blood pressure, lab values, and and the clinical observations. On the right, you can see that we loaded the data. We renamed some columns. We also can see the data on the right. Here we are checking some numerical distributions and the data heat map. On the left, you can see the Python code, and the right we can see and some the numerical distributions and the heat map. Next, we'll try to check and fill the values, as I said in the first slide, and here we will try to benchmark the chronic kidney disease data set. We'll use three machine learning algorithms, the KNN, the K nearest neighbors. It's an algorithm that make predictions based on the table of the key nearest training samples. We'll use also the decision tree classifier. It's a tree-based model that splits the feature space with simple interpretable decision rule. And finally, we'll use the random forest. It's also a classifier that as an ensemble of decision tree trained on bootstrap samples and aggregated by majority votes to improve the accuracy and reduce the overfitting. The K nearest the KNN and this is the results we obtained. We obtained the training accuracy about 0.80 with a test accuracy of 71%. In the confusion matrix, we found 53 true negatives, false positives 90, false negatives also 15, and 33 true positives. to comment this, overall, the accuracy is decent, but it leaves room for improvements. We will consider tuning this algorithm in the manuscripts. Decision tree. We achieved an accuracy of 1 and a test accuracy of about 96.7%, that indicating that a strong performance with small gap between the train and the set data sets. We found 71 true negatives, false positives 1, false negatives 3, and the true positives 45. Very few misqualifications. Overall correct prediction are high. Otherwise, it's or I can say that this algorithm offers strong results, but the training accuracy suggests possible overfitting. Item for the random forests also, it's scored a test accuracy of 97.5% with 0 false positives, for example, and it also indicates and hints that there is a possible overfitting in the random forest algorithm. Beyond the tree baseline models, the manuscript will discuss additional algorithms and their tuning. We will outline the rationale for each method's perform systematic parameter optimization within a consistent preparation pre-processing pipeline and compare performance to guide robust model selection. Now let's talk a little. Let's talk about the multi-criteria decision analysis. It's a structured decision support approach used when multiple, often competing criteria matters and trade-offs need to be made explicit. It translates diverse performance measurements and practical considerations such as predictive accuracy, calibration, equity, costs, and feasibility into a common scale and combines them across two explicit preferences. In a budget constrained health analytics, MCDA will help us to ensure decision balance performs with fairness and resources used in transparent, auditable way. MCDA also will give us for this budget where chronic kidney disease analytics, it will balance discriminations, calibrations, equity, and costs. That's it. To conclude this presentation, we focused all today on the machine learning component of our budget, where CKD analytics demonstration how machine learning can be developed, evaluated, and presented under budget constraints. The multi-criteria data analysis frameworks and its details results will be reserved for the final manuscript. The companion this talk where we will lay out the criteria, weights, or trade-offs, and sensitivity analysis. We would like to thank you again for to thank the conference committee, sessions, chairs, and organizers for this opportunity to present today, and we thank you.